On a vast stretch of land located 44 kilometers from central Sydney, more than 25 million cubic meters of earth have been excavated to create the foundation for one of Australia's most ambitious infrastructure projects. This is Western Sydney International Airport, a new aviation gateway expected to open the next chapter in the nation's development. Built across a 1,780-hectare site, the airport will feature a 3.7-kilometer runway, operate 24 hours a day, and eventually serve tens of millions of passengers each year. In this video, join Mandarin Tech as we explore how this mega project is being built and how it is reshaping the future of aviation in Australia. With a total investment of more than $25 billion, Western Sydney International is not simply a new airport. It is Australia's first major airport to be built entirely from the ground up in more than half a century, as well as Sydney's first major new airport terminal in over 100 years. The airport is expected to welcome its first commercial flight in 2026. During its initial phase, the terminal will be able to handle 10 million passengers each year. The long-term goal is to develop the site into a two-runway airport capable of serving more than 82 million passengers annually by the 2060s. And the journey to transform this rugged landscape into a vast aviation machine begins with reshaping the land itself. The ground preparation process at Western Sydney International Airport began with creating a stable base capable of supporting an international airport. The first stage focused on leveling the site and reshaping the terrain to meet engineering standards. Engineers surveyed the elevation across the entire area, then excavated higher ground and filled lower sections to form the design landscape. After each layer was compacted, it had to be inspected before the next layer could be added. Engineers measured the soil density, elevation, surface level, and load-bearing capacity. Any section that failed to meet the required standards had to be treated again, either by replacing the material or adjusting its moisture content. This process was repeated layer by layer until the ground became stable enough to support the heavy structures above. During the busiest period, more than 250 pieces of heavy machinery operated across the construction site at the same time. Excavators cut through the existing soil, bulldozers pushed material into the correct areas, and dump trucks carried soil and rock along temporary construction roads. Graders shaped the surface while rollers continuously compacted each layer of the ground. Viewed from above, the entire site looked like a vast industrial production line, where hundreds of machines worked together to transform the natural terrain into a precisely engineered surface. Once the ground preparation stage was completed, the rugged landscape of Western Sydney had been transformed into a vast artificial platform, carefully shaped and controlled according to strict engineering standards. Once the terrain had been reshaped, Western Sydney International moved into the construction of its main runway. The foundation layers were built one after another, forming a multi-layered pavement structure. Each layer served a specific purpose: distributing aircraft loads, increasing structural strength, supporting drainage, and protecting the surface from deformation caused by temperature changes, heavy weight, and frequent operations. Concrete and asphalt were laid over this foundation to create the airport pavement. In total, more than 120,000 cubic meters of concrete and asphalt were used for the runway, taxiways, and surrounding paved areas. This was an enormous amount of material, but quantity alone did not determine the quality of the runway. One of the most notable techniques used was slip-form paving, which allowed long, continuous strips of concrete to be laid with fewer joints. In airport construction, joints are always sensitive points because cracks, water penetration, or surface unevenness can develop if they are not built accurately. By reducing the number of joints, the runway could achieve a smoother and more stable surface while requiring less maintenance during operation. After the pavement was completed, more than 3,000 LED airfield lights were installed across the flight area. These lights do more than help pilots see the runway at night. They also provide precise guidance during fog, heavy rain, and other conditions with limited visibility. As the runway began to take shape, another major structure was also rising beside it, the passenger terminal. The terminal foundations were first prepared to support the heavy loads created by the steel structure, roof, mechanical, and electrical systems, and the continuous movement of passengers. Underground service areas, pipelines, cable routes, drainage channels, and spaces for the baggage handling system were installed and coordinated before the upper structure was completed. This stage was less visually impressive, but it would determine whether the terminal could operate smoothly in the future. Once the lower sections were finished, the terminal structure began to rise vertically. However, traditional concrete floor construction required large amounts of formwork, support columns, and curing time. Across such a large building, this process could create bottlenecks and delay the installation teams working below. To speed up construction, the second and third floors were built using the Australian-made Slim Deck 210 composite flooring system. Shallow steel beams were combined with floor decking and concrete to create a thinner structure, reducing both the amount of concrete required and the number of workers needed. At the same time, the apron structures and passenger boarding bridges were constructed toward the airfield. The position of each boarding gate had to match the apron elevation, fuel supply routes, ground service vehicle zones, and the turning radius of different aircraft types. Once the main frame was stable, the building had to be enclosed quickly to protect the thousands of pieces of equipment waiting to be installed inside. Architecturally, the terminal was not designed as a closed concrete block. Large glass panels allow natural light to reach deep into the building, reducing the heavy and enclosed feeling often associated with large transport facilities. From many points inside the terminal, passengers can look out at the surrounding landscape, helping the airport remain visually connected to the land on which it was built. Above the departure hall, a flowing aluminum ceiling creates one of the terminal's most striking features. Its soft curves reflect the layered landscape and mountain ridges of the Blue Mountains, while local sandstone is used on selected walls to represent the geology of the region. However, architectural beauty is only one part of the challenge. A modern airport is not judged solely by the length of its runway or the appearance of its terminal. It is also judged by how quickly passengers can move from the entrance to the departure gate, how accurately baggage reaches the correct aircraft, and how efficiently thousands of pieces of operational data can be processed every minute. Alongside the baggage handling system, the terminal is equipped with self-service check-in kiosks and shared bag drop points. Instead of requiring each airline to operate a separate area, passengers can use common facilities, helping to reduce queues and improve flexibility when flight schedules change. Sustainable energy systems were also integrated into the final stage of infrastructure development. Thousands of solar panels were installed across the terminal roof and walkway areas to provide an additional source of electricity for the airport. This is not simply a symbolic green feature, but part of a wider strategy to reduce dependence on conventional power sources and support the operation of auxiliary systems and public areas throughout the terminal. An airport does not end at the terminal walls. For passengers and cargo to reach an aircraft, a wide range of external systems must come together at the right place and at the right time. On the air side, the apron is divided into separate stands with enough space for aircraft to turn, as well as for refueling vehicles, catering trucks, pushback equipment, and baggage transport vehicles to operate safely. The pavement must support heavy aircraft standing in one place for long periods while also resisting fuel spills and the constant movement of specialized vehicles. In front of the terminal, a road network serves private cars, taxis, buses, delivery vehicles, and emergency services. These traffic flows are separated where necessary so that a queue of passenger cars does not block buses or service vehicles. Car parks, rental car facilities, and pedestrian routes are connected to the terminal by short covered walkways with clear signs. Landscaped areas do more than improve the appearance of the airport. They also help retain rainwater, reduce dust, and separate different traffic zones. Directly beneath the airport, an underground metro station is being integrated into the Sydney Metro, Western Sydney Airport Line. The tunnels had to be coordinated with the terminal foundations, internal roads, and airport utility networks from the earliest stages, because constructing an underground station after the airport had begun operating would have been far more difficult. Once all these connections come together, Western Sydney International will no longer stand as an isolated structure in the middle of a vast landscape. It will become the center of a new network where aviation, railways, roads, logistics hubs, and future urban developments grow around a single transport gateway. To understand why Australia needed to build Western Sydney International Airport, it is necessary to look back at Kingsford Smith Airport, Sydney's main aviation gateway for more than a century. Opened in 1920, Kingsford Smith once had a rare advantage. It was located only about 8 kilometers from the city center. This allowed passengers to quickly reach Sydney's business district, harbour, and most famous destinations. However, as the city expanded, that same proximity became the airport's greatest limitation. The airport is surrounded by densely populated residential areas in Botany Bay, leaving almost no space for further expansion. Extending the runways, constructing additional terminals, or enlarging the taxiway network would involve high costs, severe space constraints, and strong opposition over aircraft noise. The limitations also extend into the air. Kingsford Smith operates under a nighttime curfew from 11 p.m. to 6 a.m., preventing most flights from operating during those hours. This reduces Sydney's ability to schedule long-haul services, overnight cargo flights, and continuous international connections. Western Sydney International was therefore built to ease pressure on Kingsford Smith, expand Sydney's aviation capacity, strengthen the logistics sector, create new jobs, and shift economic growth towards the city's western region. It is not simply a solution to airport congestion, but the foundation for an entirely new urban and economic center. No mega project can transform such a vast area of land without generating controversy, and Western Sydney International is no exception. As the airport approaches its opening date, questions about noise, environmental impacts, traffic, costs, and its ability to attract airlines have become increasingly important. The airport is located near ecologically valuable areas and not far from the Blue Mountains. Construction on such a large scale has raised concerns about native wildlife habitats, natural water flows, water quality, and the environmental effects of future urban development around the site. Biodiversity offset programs have been introduced, but many environmental groups argue that these measures cannot fully replace what is lost when a large natural landscape is converted into aviation and urban infrastructure. Airlines also tend to concentrate their operations at a single major hub in order to optimize aircraft fleets, staffing, maintenance, and connecting flight networks. Western Sydney International must therefore prove that it is not merely a secondary airport, but a commercially attractive destination in terms of operating costs, transport connections, passenger demand, and freight capacity. If it fails to attract enough routes, the airport may take longer than expected to achieve its growth targets. The surrounding airport city faces its own challenges. The larger the infrastructure network becomes, the more expensive it is to develop. If infrastructure charges and investment costs discourage businesses, the growth of the aerotropolis could be slower than originally expected. In that case, the airport may still operate successfully, but the ambition of creating a new economic center will require more time to become a reality. Even so, Western Sydney International has already created a major turning point. A rugged landscape has been transformed into a runway, passenger terminal, cargo facilities, advanced technology systems, utility networks, and new transport connections. It is one of the rare modern attempts to build an entire airport from the ground up without being restricted by an outdated layout or by a city that has already grown too densely around it. From a rugged landscape in Western Sydney International has risen as a vast aviation gateway built from the ground up. Tens of millions of cubic meters of earth were moved. The terrain was reshaped, the runway was laid, and the terminal was connected to thousands of technical systems. But this project is about more than building a new airport. It is part of a wider plan to shift Sydney's growth towards the west, where transport, logistics, businesses, and new urban areas are developing together. If successful, Western Sydney International could reduce pressure on the city's existing airport, create jobs, strengthen trade, and become the center of a new economic region. However, its future will still depend on attracting airlines, completing transport connections, developing the aerotropolis, and managing concerns over noise, costs, and environmental impacts. In your opinion, will Western Sydney International truly transform Sydney's aviation system and create a new center of growth for Australia? Share your thoughts below, and remember to like and subscribe to Mandarin Tech for more stories about the technologies and mega projects reshaping our world.